This will be 15.3, rational exponents. This section, I admit, I think is relatively easy. There's not much math going on. The issue is you just have to learn how to go from a radical to a rational exponent and vice versa. So I'm going to write those notes I wrote earlier again, so you have them again for this section. But this is a radical. And to convert this radical to a rational exponent, you'll just write it as x exponents over index. So what this means is whatever number is attached to the letter as an exponent, that will go on top. Whatever number is on the index or outside the square root, that will go on bottom. So a couple of examples. The square root of x is x. Notice there's no exponent there, so there's an imaginary 1. So that's what goes on top. There's no index there, so there's an imaginary 2 for square root, so it becomes 1/2. So another example would be the square root, or sorry, the cube root of x squared. How would you write that one? Yes, sir. Oh, then we go back to the section that we just completed, and there would be no radical at all. So for example, that's a great question. If I have the square root of x squared, right? I take the imaginary 2 right here, and I would divide, and 2 divided by 2 is 1. So you're still doing the concept of exponent over index. You just simplified it down to just a regular number or letter, whatever it is. So how would I rewrite the cube root of x squared? There you go. So the 2 on the inside will go on top. The number on the outside goes on bottom. That's pretty much the moral of the story. And they go backwards. The way I like to think about it is when you're dealing with long division with fractions, the top always fell into the house. Same kind of concept when you're converting back to a radical. Yeah. All right, so let's do some examples. Oh, this makes it a little bit easier. So we'll start by making sure we know how to plug it into our calculators. 36 to the 1/2. Now, before calculators, what I would do is I would convert this back to a radical because I don't know my exponents when they're fractions. So what is 1/2 written as a radical? Just the square root of 36. And the square root of 36 is what? 6. Now in your calculator, you can actually type this in as well. You can do 36 and then rooftop. Everyone see that button? So you can do 36, then rooftop, and then open up a set of parentheses, and you can type 1 divided by 2. Go ahead and give you a chance to make sure you can get 6 out of that. You can do the same thing with the phone as well. It has a rooftop, I think. Oh, it's going to be the x to the y, where it has like a right up here, where it has like x and then yeah, yeah. Just make sure you put your 1/2 in parentheses with the calculator. Good. If not, it'll take it as that number to the first power divided by 2 versus all together. Do it in parentheses, yes. Because if you don't, it'll take that number, raise it to the first power, then take that answer and divide it by 2. Ooh, that's nice. That's good. Then that means your calculator understood that it was supposed to be 1/2. Some calculators don't follow. Did it give you the answer? You're good. So let's see. So 36 Rooftop is this button right here. So I just hit that and say I made it tiny. Then I'll just do 1 divided by 2. Execute. Yeah, like that.
Oh,
Yours just makes the division sign versus the slash bar,
okay.
but still the same concept.
Same.
Yeah.
Okay.
Mm-hmm. All right, so let's try. So that's A. Try this one. B to the 16th raised, not B, sorry. Letter B is 16 raised to the 1/4. And all you have to do on the first set of your homework is just evaluate it. So you just got to figure out what the answer is. It'd be 2. And again, what this turns into becomes the 4th root of 16. So you're trying to think of what number times itself 4 times would give you 16. In this case, it's 2. But you don't have to stress about that. You just type it in and get the answer. Yeah, in the first part of your homework, that's all it's asking you to do. So part C, try one like this. First, yeah, no, yeah. It not, in my opinion, not necessary because it's just rewriting it. It's not actual simplifying or doing work or yeah, I don't know. I can be biased, I guess. All right, so try that one. 0.0016 raised to the 1/4. Yes, because the whole thing is being raised to the 1/4. My rule of thumb, if it's written like that, go ahead and type it like that. But I don't think it's going to matter on this one. I think you could do it without parentheses and still give you the same answer. But I will say that makes me nervous a lot with calculators, especially if you don't know what the answer's supposed to look like. It's still going to shoot out an answer. That's it. So 0.2 would be the answer. Mm-hmm. Raised to the 1/4 or 1/2. Yeah, this is 1/4. This one here with a radical? Oh, that's fine. I can rewrite this as the 4th root. Am I recording? Yeah, okay. Yeah, so yeah, 0.2 would be the answer. So in this case, 0.2 times 0.2 would give me 0.04 times 0.2 would give me 0.008 times 0.2 would give me 0.0016. So 4.2s would give me the result I need. Decimals can be a little hard, but just make sure you can type it in the calculator. All right, try this one. And this becomes a good question you just asked, Dante. Do you have to write the parentheses? In this one, you do. This is parentheses -27 raised to the 1/3. Because it's a negative. If you don't have the negative, your calculator won't adjust the negative and it will give you the wrong answer. Well, actually, ooh, I lied. This one won't matter either. But a square root will or something like that. There it is. Make sure we can all get -3 before I move on. You do 1/3 or 1/2? Yeah, it should still work. I know, I know. Pretty sure I've done this question on my own phone. What? Let's see. Hold on. Oh, clear? Oh, okay, you have to type the number first, don't you? So it was negative 27 to 27, make it a negative. Then next to the y, 1 divided. Oh, nope. Got to put in parentheses. 1 divided by 2. Yeah, I don't know why it does that. Hmm. -3, right? Yeah. Yeah, I will. I mean, it's going to probably come out the same, but that's super weird on why it does that. I wonder if there's like a float or something we don't see. Yeah, no, mine gave me the same answer. Yeah, I don't know why the phone doesn't. Yeah. All right. Well, on problems like that, don't trust the calculator or the cell phone. It is -3. I don't know. I don't know what the calculator's trying to do. Because I guarantee you, I bet I could do the cube root. So let's do that. So, oh, 27. And if I want to do the cube root of that, yeah. So the cube root of -27, it comes out as -3. So maybe on this one, best practice for your cell phone, don't do the fraction. Yeah. Convert it into a radical. So then type this into the calculator. And on my cell phone, it did pop out -3. Yeah. So if you're going to use the cell phone and stuff like that on your homework and stuff, make sure you get a regular one because you can't use a cell phone on the test. Yeah. But I would convert it to a radical. All right, so we feel pretty good then typing these into the calculator at least. All right. When you on your regular calculator, you should be able to type it just like this and be just fine. Because what kind of calculator do you have? Yeah, it'll work just fine. 84s. It's the rooftop. It's the thing. I think it's called a carrot or whatever, but it looks like a rooftop to me. So, hmm. I got you. I'll pull it back up. Yeah. It's like number 4, ain't it? Yeah. Mm-hmm. Thought I survived college for some of my classes. Yeah. The older I get, the less I have of it, or I can remember for less amount of time. All right. So on this one here, you're just going to convert either to a radical or to a rational exponent, depending on what you're given. So on the first one, we are given x raised to the 2/5. So we need to turn this rational exponent into a radical. So how would I do that? What would it look like? Perfect. It's a good start. Radical. 5 at the top. Very good. There it is. You don't have to write the 2. So on your homework, it won't allow you to write the 2. You have to choose the square root. You can't choose the other button that allows you to type the index because it'll count it wrong. So make sure when it's a square root. Oh, whoa. Actually, sorry. Does the 5 go there on that as the exponent? It'll be on the outside because if you think about long division, the top number falls into the house. So this would actually be a 2 right here. Which then the 5 would be the index. Yeah. Because the top number goes into the house, and then the bottom number is the index number. X to the second power. Sorry, my arrow got my way. That becomes 2. There you go. No, I mean you could if you could, but in this part of the section, homework, there's nothing to simplify. I just want you to rewrite it. Plus, if you could simplify, you could simplify your fraction from here before you even convert it. Like for instance, let's say it said 4/10, right? You would turn 4/10 to 2/5, and then now you have a reduced fraction. All right, so look at B. So now we have one that's 8z raised to the 6/7. Oh, I will say that was one thing about being on the cruise. There's about 1,000 teenagers, and that is all I heard when I walked out. Oh, I was like at the high school, I thought that was bad. On that cruise, I was like, I feel like I'm back at work. Like, no, there's some meme or something on sick. It's some meme. Ooh, I like where you're thinking. Dante asked a great question earlier with the parentheses, right? I don't know if it was on this one or it was. Notice this had parentheses, so the entire thing was raised to the 1/3. Notice this does not have parentheses. So the 6th, 7th would only apply to what? Just the z. So this 8 would not go in the radical. It would just ride along for the ride. So then in your radical here, you would have your z there, but the 8 would stay up. There you go. Top number falls in, bottom number stays out. But that will say on your homework, that's what's going to get you is you're going to try to take that number and throw it in the radical. And now, again, alternatively, had it asked this question, 8 times z raised to the 6th, 7th, now this becomes 8z inside. But even then, you still need a parentheses around the 8z because the entire thing is being applied to the 6, the 7 on the outside. So watch out for things with no parentheses and things with parentheses. We good? Try this one. Or Matt. Negative b raised to the 5/4. Well, technically in kindergarten, you had negative b's there as well. We just didn't call them that. We called them fishies. So you would have 2 fishies minus how many fish would give you 1 fish. So instead of like blank boxes where you had to fill in or draw a picture, now we just add letters and we say, all right, this mystery number is now a letter versus just an open box or a question mark or something like that. Ooh. Okay, so where's that negative going? Outside. Very good, because it's not in parentheses. You got carried over. Good. So the 5 would drop inside and the 4 would stay outside. That's good. All right, so we're good going from rational to radical-ish. Now you got to be able to go the other direction. So now go from radical. So we'll do the seventh root of x to the fifth. There you go. So try this one. That's it. So this one, since it fell in, now goes on top. Well, on the bottom part. There's no more radical at this point. So try 3 square root of s. That's an s, yes. Yep, it sure did. It's a big 3. Yeah, that 3 is not an index, so that's a big 3. Ooh, there it is. There's an imaginary 1 for an exponent. Yeah, it's an s. Hold on. Let me rewrite this. I don't know. It still looks like a 5 to me. I don't know how to how do y'all make y'all's s's not look like 5s? I don't know. Looks like an S. I'm about to go old school into the 90s and start writing my s's like this. There's an imaginary 1, and then divide it by the imaginary 2 that's on the radical. Index, yeah. All right, try this one. Negative fourth root. This time it is a 5. Good. There's an imaginary 1 over 4. We're missing anything? The negative. The negative has to go with it. Oh, all right. So that was the easy part of the homework. Now it's going to take what you learned back in lesson 13, the beginning of 13. Oh, sorry. Yes. So there's an imaginary 1 right here, and then the index. So the 1 would go to the top of the fraction. All righty. So where am I at? So on number 3, we're going to now take things that look like this. X, this is part A, to the 1/3. Yeah. Times X to the 1/4. Now, what do I do when I'm multiplying like bases? What do I do with the exponents? Okay, keep the bases. Perfect. What do I do with the exponents? I add them. So now we have fractions to add. So 1/3 plus 1/4. They have to be the same. So how do I make them the same? So what number does 3 and 4 both go into? Very good. So what I can do is, what do I have to multiply 3 to give me 12? Very good. And what do I have to multiply the 3? So I got to do the same thing to the top. So now 1 times 4 is, this gives me 4/12. Plus, what's 3 times 1? This gives me 3/12. Very good. And the denominator would what? Stay the same. So it stays 12, and I do 3 plus 4, or 4 plus 3, and I get 7/12. So yes, it does give you a decimal, but on your calculator, you can convert it back to a fraction. Yeah, I don't know if our phones convert back to a fraction. Yeah, but your regular calculator will. So what you could do if you're still scared of fractions, which I totally understand, you can just do 1/3 plus 1/4 in your calculator, convert it to a fraction to get your answer. And I'm okay with that. So that's your question? Yeah, so this is doing it by hand, but I'm good with y'all typing 1/3 plus 1/4. Just make sure the answer comes out as a fraction. Math number 4. And then enter, I assume. Nope. Plus. You're still adding. They come out? Perfect. So in this case, we have a raised to the 4/9 and a raised to the 2/3. What do I do with like bases when I'm dividing? I subtract the exponents. So in this case, I now have 4/9 minus 2/3. Very good. So even with subtraction, you have to make sure the denominators are the same. So I can convert that 3 into a 9 by multiplying it by 3. And if I do it to the bottom, I have to do it to the top. There you go. So I'm trying to make that A curly. So it's not a Q. I'm just trying to make sure it's not a 9. So I got 4/9 minus what's 2 times 3? And then that 3 times 3 is 9. And so now I can do the subtraction. What's going to happen to those 9s? Stay the same. Ooh, 4 minus 6 would be -2. Now, let's see if y'all can remember from 2 sections ago. What happens when I have a negative exponent? How do I make it positive? There you go. Drop it to the bottom. Makes it a positive. But what happens on top? Put it over 1. Perfect. So we're good there? So let's try this one. 3 times b to the 1/5 raised to the 4th power. And it'll work this type of problem. You weren't here for those units. Yeah, it's our 1/5. Multiply what? Okay, I agree. As an exponent? Perfect. So that does become 3 to the 4th power. And what is 3 to the 4th power? 81. And then what's 1/5 times 4? 4/5. So on the biggest part of this one, make sure this exponent gets applied to every term inside. Right? Which is 3 times 3 times 3 times 3. Well, 3 to the 4th power. I got 81. So this is 3 to the 4th power, not 3 times 4. What you do multiply, though, is any exponents. Those you multiply. Good. And y'all took a test over this. I hope y'all really learned it. Correct. Because you multiply a power raised to another power. So 1/5 times 4/5 looks like this. 1/5 times 4. A whole number can be turned into a fraction by putting it over 1. And then with multiplication, we move it, multiply straight across. So 1 times 4 is 4. 5 times 1 is 5. All right. Let's try another one. Let's try 64 times z to the -4/9 raised to the -1/2. It's a 9 too, by the way, on the bottom here. Well, technically, if you apply the negatives, they'll become positive. So if you want in your calculator, you could just do 1/2 times 4/9. Because it'll, it's going to be positive as an answer. Not stress about the negatives. If you type it into your calculator, it will. Yes, it's going to get hard now with your decimals to fractions. Yeah. Yeah, like that. So in this case, this becomes 64 raised to the -1/2. It's going to have to apply the exponent. And it does come out as 1/8. And then -4/9 times -1/2 does give us z to the 2/9. Now you can write it like this, but your homework might want you to write it like this. Because the 1 times this would just be this. I like this personally better, but your homework tends to like this one better. Mhm. Let's try this one. Negative 49 raised to the negative 2/4. Ooh, did it one more time. Sorry. Oh, no, no, no. This is 64 raised to the negative 1/2. So this is a power here. I multiply the exponents that are already there with the exponent. Yeah, so this case, I would not be multiplying. In this case, I'm raising negative 49 to the negative 2/4. 4. Mhm. Very good. Here's the reason why. What does 2/4 simplify down to as a fraction? 1/2. Negative 1/2. The negative just means it's going to be a fraction, correct? So I'll go ahead and rewrite it for right now. So I could say that this is where I'm at right now with it. And what do we know a 1/2 exponent is? So anything to the 1/2 is just a what? It's just a regular square root, right? So in this case, this would be saying the same thing as the square root of negative 49. Can I take the square root of a negative number? Not possible. So yes, by getting an error, you got the right answer. Not possible. Not a real number. Whatever answer it gives you there. All right, let's see how you do with this one. 16 to the 1/2. Four. Again, that 1/2 will give you that square root of 16, which is 4. Or you could just type in. So the 1/2, so the 1 dropped inside, and then the 2 is a part of the imaginary. Mm-hmm. Well, it ends up being the square root of 16, which is 4. Mm-hmm. Or you could just type this in. Yeah. Because that right there ends up just being the square root. All right. If you didn't think it was hard, it's good. I want you to write this as a simplified radical. The fifth root of the second root of x. That's crazy that it's the 2. There's 2 of them now. This is the fifth root of a square root of x. All right, here's the best approach. turn these radicals back into fractions. So in this case, this would be x. What is the square root going to turn into as a fraction? 1/2. Raise that. What is the fifth root going to turn into as a fraction? 1/5. So even though it looks like this, the real question is, this is x to the 1/2 raised to the 1/5. And what do we do with powers? We just multiply them. So what's 1/2 times 1/5? 1/10, which is just 1 times 1, 2 times 5. Now, it wanted the answer as a radical. So now turn this back into a radical. Correct. So I will say on this part of the homework, I didn't pay attention. I wrote this as my answer and got it wrong because the directions says to write it as a radical. So I'm cautioning y'all. Make sure y'all pay attention to the question and make sure you write it as a radical. When I got that wrong, I was like, got it wrong? What? I was like, oh, radical. That's what it said. Yes, this right here is called a radical. All righty. What's our approach here? Because the fourth root would become 1/4. There you go. And so now I'm multiplying like bases. What am I going to do with these exponents? Add. When I multiply like bases, I want to add the exponents. You could do that, or what's 1/4 plus 1/2? And how do you write 75 cents as a fraction? There you go. So totally, you could turn this and multiply it by a 2 and do 1 times 2 and get 2 plus 1, which is 3. But some fractions we use a lot in the kitchen, and feel like we should know 1/2 plus 1/4. That's 3/4 cups. Oh, now remember, this answer's not done. Yeah. Yeah. So this problem's not done because it needs it as a radical. How would I write this as a radical? There you go. The top number falls into the house. All right, let's try this one. Cube root of x squared times the square root of x cubed divided by the sixth root of x to the fifth. Yes, that's cube root of x squared times the square root of x cubed divided by the sixth root of x to the fifth. Mm-hmm. Very good. What's the imaginary? It's imaginary two. Are we just playing with the top first, or do we want to mess with the bottom? Okay, that's fine. So how do I simplify the top there? Very good. So it's 2/3 plus 3/2. Yeah, that'd be two. So that'd be four. That'd be nine. 9 plus 4 is 13. Yeah, 13/6. This one you would multiply by two, and this one you would multiply by three to make the denominator six. Oh, you're doing the bottom? Sorry. You're good? So x, 5/6. Subtract. Very good. Very good. And 8/6 would simplify down to, ew. There. So 4/3, totally agree. That would be a cube root of x to the fourth. What if I told you this is wrong? You didn't do anything wrong. This is technically a answer that's correct, but not the simplified version of the answer. Notice all the wait. All the fractions that we dealt with were not improper, meaning the denominator was always the bigger number, right? If we go backwards, we can see this was 2/4, 2/9, 4/5, 2/9, 7/12. We never had a situation where the numerator is now larger than the denominator. When this happens, to simplify it, you have to ask yourself, 3 goes into 4 how many times? One time with a remainder of 1. So that'd be a cube root of x. That would be the answer that your homework wants. Correct. Yeah. We haven't done anything wrong. Yeah, we didn't do anything wrong. We just didn't finish it. And you only have to do this part if you are end up with a what they call a mixed number, which or an improper number, which is when the numerator is larger than the denominator. Correct. When I multiply like bases, I'm going to add the exponents one. Correct. Yeah, because you'll get down to the cube root of x to the fourth and won't even notice that you have one larger. Yeah. It's going to say that word simplify, and that's all it's going to say. So you have to know, all right, if I end up with an improper fraction, I need to simplify it to this point. Yeah, if the exponent is bigger than your index, you need to keep going. Because this basically just goes right back to 15.2 that we just got done doing, where I would go, all right, let's take the 3 and divide it and go, oh, it goes into it once with a remainder of 1. All right, for this last part of the homework, is this going to ask calculator questions, meaning can you just type them in and get the correct corresponding answer? So 64 raised to the 4/3. In this case, we're just looking for a number. When it says evaluate, we're just looking for a number. We don't have to keep it as a radical. So this actually comes straight up 256. Everyone get 256 before I move on? So it'd be 64 and then raised to the 4/3. 4/3. Oh, the house. Rooftop. By hand? You could. All math can be done by hand. So this right here, the way I would do it, and I say this because I had to do my entire undergrad and grad without a calculator. So the fact that we allow calculus now, when I first became a professor, I was like, what? They need to struggle like I struggled. But then I'm like, I guess it's 21st or 20. Well, what century we in? What, something. Yeah, technology century. So you're always going to have this in your hand. So let's make sure we know how to use it, right? So in this case, I would write this as a radical. So I would say, all right, let this be the cube root of 64 to the fourth power. And I would pretend right now that this is kind of like an X. So I'm going to say, all right, well, 3 goes into 4 one time. So I have 164 on the outside. And then I have a cube root of 64 left inside. Then from this, I'm going to try to think of a number times itself 3 times. That would give me 64. Maybe I can't think of it right away, but I do know 64 would be 4 and 16, and then 16 would be 4 and 4. So I'm like, there we go. So this actually ends up being 64 times 4. And then I do some vertical multiplication here. Yeah. That's because I was already in the trenches here. Oh no, I don't. I'm going back to school next year or for just a principalship. I don't know. I didn't think I was going to go back that quick. I don't want it. But I said I didn't want my master's either, but let's see what that happened. All right, try this one. Go to 4 decimal places on this one. 42 raised to the 5/6. 4 decimals to the 10,000ths place. Yeah. All right, so 5/4 talks about adding and subtracting and multiplying and dividing radicals. So I think that's a good place to start on Wednesday. So make sure you're working on 14 and 15. I'll try to get the rest of chapter 14 posted by tomorrow. I think it's just 2 more videos I got to make, and it's solving the radical. Hmm? They're in Blackboard. Yeah, you go to week 1, week 2, week 3, and when you hit that button, and then it has every section. So I'm doing all this work, and only 2 people are